Hey guys, this is the video lesson for our inquiry lab on solving one-step inequalities. So let's get started. The problem says, in a recent Kentucky Derby, the total weight a horse could carry was less than 126 pounds. A jockey, that's the person who rides the horse by the way, weighs a certain number of pounds, and his equipment weighs 9 pounds. How much could the jockey weigh? So let's go through and circle some things that are important here. First off, the total weight a horse could carry was less than 126 pounds. A jockey weighs a certain number of pounds, which means we don't know how much he weighs, and his equipment weighs 9 pounds. The question says, how much could the jockey weigh? So we can use maybe X to represent what the jockey weighs, because we don't know that. So here's what we know. The total weight a horse could carry is less than 126 pounds. And the jockey's equipment weighs 9 pounds, and we have to figure out what the jockey could weigh. So we're going to show you how this would work on a number line, and then we're going to take the number line and write our inequality. So let's go down and take a look at it here. If you look at this number line, which I'm going to white out real quick. All right, that's better. So what we're going to do is we're going to draw a bar diagram on this number line to help us represent this. So first off, let me zoom in so you guys can see. And you can just watch this one because I know it's already done in your book. You don't have to actually write anything. So I'm going to draw a bar to represent what a horse can carry. So remember, right about here that I just put a mark there is 126 pounds. And we know the horse can carry less than 126 pounds. Can't be 126, but he can carry less of it. Now, what we know is that the equipment the jockey's going to carry is 9 pounds. So if I were to go 9 less than 126, that would take me down to 117. So I'm going to put a little line there. Okay, so 117 would be right about there. And I'm just going to mark it 117 pounds. Now this section right here represents the 9 pounds of equipment that the jockey has to carry. And that means the rest of the bar represents the weight that the jockey could be. So if we're looking at this, remember this 117 is what we got when I took the 9 away from the 126. So by understanding that, we know the jockey has to weigh less than 117 pounds because this 9 pounds is going to be the equipment that he has to have. So that's how I could use a bar. Now the jockey, that doesn't mean the jockey weighs 117 pounds. He's going to weigh less than it. He could be 116 or anywhere down to 0, which isn't really possible though. So let me show you what this would look like as an inequality. So our inequality would be that whatever the jockey weighs plus those 9 pounds has to be less than 126 pounds. So that's our inequality. Now, the solution would be X would be less than 117 pounds. That means the jockey, remember X is what the jockey weighs without the equipment, has to be under 117 pounds. All right, so that's kind of what we're doing here with the inequalities. Now, on the next page is where you're going to do some. All right, so let's start by reading number 1 here. It says, Regina sent X text messages before lunch. Let's circle that. So X text messages before lunch. And she sent another 4 text messages after lunch. So I'm going to circle that, and I'm going to write after up here. And it says she sent less than 7 text messages today. So they would be her total text messages. So the question says, how many text messages could she have sent before lunch? Write your answer as an inequality. So we don't know how many text messages she sent today. We just know it was less than 7, right? It could have been 6. It could have been 5. We don't know that. So what we're going to do here, and do this with me, is we're going to draw a bar from 0 all the way to 7. Now remember, that represents what she could have sent today. All right, anything in that bar. Now remember the parts we know. The first part is she sent X messages before lunch, and the second part is she sent 4 text messages after lunch. So what we're going to do is we're going to mark off the 4 that she sent after lunch. So remember, we start here. So this would be 1, 2, 3, 4. So right here, we're going to put a line. So these are the 4 messages that we know she sent after lunch. Now, anything before that are the text messages that she could have sent before lunch. So if we look at that, let me get my pointer ready here. Since this line is here, X has to be less than 3. Okay, so that means she could have sent 2 text messages, 1 text message, or 0 text message before lunch. All right, so now how would we write that as our inequality? Well, take a look at our bar, and it should look like our inequality. X plus 4 has to be less than 7. So that's our inequality. Now what we're going to do is I'm going to show you how to solve this inequality like you're going to learn in tomorrow's lesson. So let me zoom in here. Now we solve inequalities just like we solve equations. We use inverse operations. So we want to get the x by itself, and to get rid of a plus 4, we subtract 4. So we're going to do minus 4, and we do the same thing to both sides of an inequality, minus 4. Cancel. Now we don't bring down an equal sign, we bring down our less than sign. X has to be less than 3. That's our solution to our inequality. So x can be any number less than 3. Now remember when I looked over here, how here was my 3, and x had to be less than it. All right, now since it's text messages, it's not going to be 1.5. You can't send 1.5 text messages. So the answer would be 2, 1, or 0. Okay, so that was the first one. Now you ready for the second one? We're going to do the same thing, so stick with me. Oh, let me zoom out and have it stay. All right, so this one says, we'll start reading here. A player with 5 personal fouls cannot stay in the game. So as soon as you have 5 personal fouls, it sounds like basketball, you foul out. You can't be in the game. Dylan has already earned 2 personal fouls. So we know he has 2. How many more fouls could he earn and still stay in the game? So we want to know how many more could he earn, X, and still stay in the game. Write your answer as an inequality. All right, so let's think of that here. We're going to go down to our bar and draw it. Okay, you ready? So first thing, to be in a game, you have to have less than 5 personal fouls. So we're going to draw a bar all the way up to the 5 here. So that whole bar represents the fouls that you could have. It has to be less than 5 to stay in the game. All right, now we know he already has 2 fouls. So we're going to count down from the right. So we're going to count down here, 1, 2. So we're going to put a mark right there at the 3. This represents the 2 he already has. And the question says, how many more could he still have and stay in the game? So that's going to be everything over here. Now take a look where the line is. The line's on the 3. So he has to have less than 3 personal fouls. That's what X is. If he has less than 3, he can still stay in the game. As soon as he hits 3, he's out of the game. All right, so now we're going to write that as an inequality, and we're going to solve it. Now we know the answer is X is less than 3 because we just figured that out by looking at it here. It has to be less than 3. But let's show you the inequality. So first off, just like our bar, you see how we have the X and the 2? We have X plus 2 is less than 5. Now remember, the X are the fouls he could have, the 2 is what he definitely has, and they have to be less than 5. So to figure out what X could be, we subtract 2 from each side. So we do minus 2, cancel, and we have X is less than, and 5 minus 2 is 3. So he can have less than 3 fouls and still be in the game. All right, so I hope the number line helps you see it a little bit more as a bar diagram than just writing numbers and symbols. But now, the last thing we're going to do is we're going to do just 3 and 4. Now, the directions say to use guess, check, and revise strategy, but that's kind of a pain in the rear end. So we're just going to start with how you're going to learn tomorrow and what I just did with you in number 1 and 2. So to solve this inequality, We have x minus 5 is less than or equal to 1. We want to figure out what x could be. So just like an equation, and you could do this with me, we have to undo the minus 5 with a plus 5. Do that on the left. Do that on the right. Cancel. We have x. Now, a lot of times people accidentally write an equal sign because you're used to equations. But remember, we've got to bring down this sign. X is less than or equal to, and 1 plus 5 is 6. So our solution is x could be anything that's less than or equal to 6. All right, now we're going to go to number 4. This one I want you to try on your own. So our inequality is x plus 3 is greater than or equal to 8. Solve it just like an equation. Just remember, don't bring down an equal sign. Bring down this sign when you solve it. Pause the video. Try number 4. Go. All right, let's see how you did. So first off, to undo a plus 3, I hope you did minus 3. And if you do it to the left, you do it to the right. Cancel. So I have x. I bring down my greater than or equal to sign, and 8 minus 3 is 5. So our solution is x is anything greater than or equal to 5. All right, you're done with me for the video. So it's a short inquiry lab, and tomorrow we're going to be focusing on writing and solving inequalities that are one-step inequalities. As always, thanks for watching.